And this is just to mention, all this data is from Eberhard Riedel that I'm showing for the predictions and maps that we publish. This just shows where the resources are for grazing occultations. We publish maps. Eberhard publishes maps and lists of grazes of stars brighter than 5th magnitude for selected areas. They're published in the JOE issues just before the start of each year. The areas that he publishes for are US and Southern Canada, North America, Europe, Middle East, and Australia, New Zealand, and Southern Africa. I think we're going to have to add an India one to that, or South Asia or something, maps to cover in the future for the Indian group is very active now. So anyway, we have, besides those in JOA, which you can freely get from the IOTA website, similar maps and lists are put to magnitude 7.5, so more extensive coverage is given in the RASC Observer's Handbook. These maps and lists, as well as tables of the limit data at 1 degree interval, which are not available in those publications, are available on our website, our GrazeMap website. And that website, in addition to having all of this data, has also worldwide grazes, maps of grazes, grazing occultations of lunar grazes of stars and planets of magnitude 3.0 and brighter. And of course, you can generate your own graze predictions for even fainter stars using GrazePrep available at the above website, or you can use them with the occult software, which is at that website. So this just shows the map for North America from JOA last issue of 2019, showing all the grazes for 2020, the 5th magnitude and brighter. I just point out the January 2nd graze is 33 Pasceum, although it was not the first graze of the year, because 33 Pasceum is kind of a paired red giant star with 30 Pasceum, which occurred a few hours earlier over Georgia. So that was number 1, and this is number 2. And you can see the other events. There might be some from you, but of course, these are just the very most spectacular events, the very best events. This number 11 down here was a graze of southern limit graze of Mars. Anyway, go to the next event. This just gives a table corresponding to that map. I'll post these on our website, and you can see these, get the information in more detail. So don't worry about trying to remember or look something up. But the way to work this is, with the map, you can see the event you want, and then you can see the index number, and you go down and you can see which date it is and the information about it, the magnitude of the star, the ID of the star, and the percent sunlit. But most important is this longitude and latitude of the west end of the path. So if you want to see where a particular event is, you go to those numbers and then find them on the map. It gives information about the star's duplicity and so forth. So anyway, now this is from the GrazeMap website showing the worldwide grazes, just showing the grazes during the rest of the year that are visible in worldwide areas. In these cases, the black lines mean the grazes on the dark limb at night. The blue or the yellow lines mean that the graze is on the bright side of the moon, but during the night. And the blue lines means that the graze is either on the dark or bright side, but it's during the daytime. But the these objects are all bright enough actually to observe in the daytime with a telescope. So the whole full paths are shown. Anyway, this just shows the 2021 map that'll be in the RESC Observer's Handbook. Grazes for January 1st through the 15th. I'll just show that we have the data, and we're in the process of preparing the information for the handbook now. It's and this is the table of events for that first map. So I'll just, and then just to conclude my talk, I'll just go through the slides for the rest of 2021 so you can see. I'll just spend a few seconds at each one and you can see if there are any events near you. And so forth. You say these are the RESC coverage, which is down to 7.5. So there are more events than are given in the JOA. And then finally, this event, the dotted line here means a bright limb event or a daytime. This is a daytime event. I think it's a Mercury or something. It'd be hard to see. And here's another event one's on the bright limb and one's on sunlight. And these are the last events of 2021. So with that, I'm supposed to end at 3:40, and so we have 4 minutes for questions. That's the last slide.
Thank you very much, David, for your work in preparing this. I think you might have attracted a few more graze observers. It's enticing just to see all those lines close to my home.
Yes. See, I mean, since the late 1970s, interest in grazes has decreased considerably as interest in asteroid occultations pick up. And certainly the scientific return is much greater with the asteroid events, and we certainly concentrate on those most. But when you have a very nice graze visible near your area, you might take your telescope out and try to observe it. They are fascinating events to observe, and there's a little bit of science we can get, as we showed.
Also, potentially a very good recruiting technique, because
yes, exactly.
They're a good group event.
Right. I mean, that's how IOTA really got started, and with the large groups that we had. Of course, in the visual days, you only could have as many stations as you had pairs of eyes, and so we had to do it that way. And these days, unfortunately, we have fewer people involved in the overall effort than before, but hopefully we can help turn that around by multiple techniques, bringing costs down and so forth, and showing this is important work. It gives great training for the asteroid events, the lunar events, as well as also discovering close double stars and so forth, or showing that past claims don't exist.
You can also see a piece of old grazing observed technology. And David and I are standing on it in that picture of us from our wedding, a graze cable that I use as my particular photo, because this also happens to be very close to our 50th wedding anniversary.
Yeah, I actually have a slide about that in the talk I'm going to give tomorrow. I end it with the full picture, so we'll show it then.
We will stay tuned for that. Congratulations in advance.
Mm-hmm.
David, can you say again, how big was the shift on that graze, on the north-south part of the moon?
It's of the order of I think it was about 2/2 of an arc second or so. Yeah, that's the sort of accuracies we're dealing with grazes now. I mean, we can predict all those nooks and crannies that before we couldn't, you know, with the Kaguya, and now the LRO is even better. You know, profile data is really detailed, and but you know, there's still very small things that we resolve that aren't even in that data sometimes. But it's but 2/100ths of an arc second. That's something of the order of like 50 meters or so, or a little bit greater. You know, partly the diameter of Aldebaran is I think about 10 meters at the moon's distance. So we're almost down to the angular diameter of the star. You could see during that graze the gradual events that was due to Aldebaran's angular diameter.
It still seems larger than what you would expect, I think, doesn't it?
Yeah, so a little bit. As I said, the laser ranging data are of the order of a few meters in their accuracy, and so we're seeing you know, the shifts that we saw there are a little larger than that. You know, are about 10 times that size. So I think there is some modeling to do there. Whether it's, you know, just determining the, you know, back in the early days, when we had Watts data, which was really pretty poor, we made special efforts to observe grazes at both the north and south limit of the same occultation. And we could only really do that during total lunar eclipses. And we'd always have trouble with one limit or the other with weather and logistics and everything. So there's some interesting tales. You know, Paul Maley traveled far and wide for some of those events. But now we're kind of seeing the same thing on a much finer scale. I think it's just a matter of the complexity of the lunar gravity field and modeling. You have to model the orbit as well as the surface of the moon. And the two of those things, I think, maybe are not quite as accurate as people think they are. Now, certainly the position of the moon is well known for the laser ranging data, you know, to under a meter accuracy. So it's an interesting problem. Now we have good data for the stars. I mean, so we'll see.
All right, thank you.
David, a question.
Mm-hmm.
On the maps, the graze maps, how can we tell from just looking at the maps on which side it would be an occultation and which side it would be a miss? I noticed there's like some hash marks.
Right. Yeah, the hash marks are, the tick marks are on the extend south of northern limit grazes, and they extend north of southern limit grazes. So the hash marks point to the area where the total occultation is visible.
Okay, thank you.
Okay, Dave, thank you very